Okay, so here I am with this power supply for the Death Race. And here is the Death Race PCB. And it's all TTL, and it's lots of it. Lots and lots of it. But we'll get it. I do have the power supply with this, obviously, and I looked at the schematic for this, and it didn't really make... It's hard to read, for one. And this is the model. Okay, I got the model here. As you can look this up on the model. It's hard to read. It's hard to read the schematic. And there's a couple transistors, I suppose these are. 10K60, 10K60, and then this Vero R711A. I have no idea what those are. Yeah. So this is the EAPS 5-10. Yeah. Fuse externally for 5 amps. It said. Okay, this is the input. This is the these two leads right here are your AC in. This is just ground. This is a ground, earth ground. And then this is your outputs. It's basically, you have a 20 volt AC tap for audio, and then a bunch of 5 volt and ground wires, and an extra ground here. So that's really all there is to it. Like I said, though, it really, that schematic is really hard to look at. I don't really... Yeah, see? That's a diode of sorts. You see that? That's that Vero 711 thing. And that looks like a diode, CR2 and CR1, a double diode. Very strange. This all has to be removed, though, because I want to recap this. I want to check all the components on this, make sure everything's good before I move forward with it. And I'm going to replace this cap, so I need to look at the actual value and everything, and I'm going to source a cap for this. Yeah, so some work to be doing. I'm going to go ahead and just start taking this apart and getting this little board out of here. I want to check all the capacitors on it. This is from 1976, so I want to make sure that all of the disc capacitors are good, all the resistors are good. I want to check everything and replace the electrolytics. Just go through it. Due diligence. Okay, I got it out of the case. Unfortunately, because of where this one was positioned, I had to drill this thing out. So I'll have to remount it with just some 6x32 screws and a little nut to go down in there to remount that. So no big deal, but yeah, it had to come out. So we've got this thing out now. Now I'm going to unhook it from the transformer. Document well where these wires are going. And get to this guy. Okay, I think I've found one issue already. Now I remember when I was looking at the schematic for this guy right here. See the CR1 and CR2? This is a double 3 amp diode. And the case is the anode, and it's got 2 cathodes. So what it is the AC comes into the case, and the rectified DC comes out of the cathodes. Here's one AC. That's the No, that's DC out. Maybe I got it the other way around. This is filtered AC right here. So the case, not filtered AC, filtered DC. So the case of this thing has to be the cathode, because that's where the rectified AC is going to come out of. I can't do this one-handed. Let me mess around with this and I'll be right back. I will report back. Okay, I was able to do some looking this stuff up. This thing, this Vero 711A, is a dual rectifier, common anode, and the common anode, the case is the anode, and the two diodes are obviously, the two leads. And it's no good because we have, let me get the tripod so that I can do this. Be right back. All right, I got you set up there. You can see the diode drops. Remember, it's common anode, so we put our red lead on the case and then touch both of the legs coming up, and we should get our diode drop. This side, all good. This side's open. And this is a dual diode, so common anode. This thing is no good. And that is unfortunate, because that thing says, I looked it up and it says it's 30 amp. Common anode, 30 amp. Boy, yeah, we're going to have to think about that. Find a replacement. It might be a little... I can't just put 3 amp diodes in there. This is a 30 amp thing, so yeah, that's not gonna work. So I need to figure a replacement for this. Common anode. I wonder if I could use half of a 35 amp bridge. Just the positive, the positive output on it. I got to think about that. And here, these other two transistors are Darlington, NPN Darlington transistors, and the way these read make no sense. Okay, this is NPN, so we will have base to collector, nothing on this one. Base to emitter, we do get our drop. We get this base to emitter. And then we switch the leads, we get our regular base to emitter. And here we have, this one does have base to collector and base to emitter. But you reverse your leads, base to emitter, you get this. And I'm going to have to look at the schematic a little bit better, because I know you are supposed to get a double diode drop. But I just don't see it as being across here. I'll check it out though. And let's check collector to emitter. Nothing. And we're getting a drop collector to emitter. And that's right, because the collector to emitter there is a damper diode from collector to emitter. So that's actually correct. This one's open. This one's dead. This one over here, unless it's complementary. Let me look at the number. 10K60. 10K60. Now these are the same thing. This one is just, one of them I think might be good. I have to check that. This reading from base to emitter, reverse polarity, reverse biasing, you're getting 2 diode drops base to emitter. I got to check into that. You're getting the same thing on this one. No, you're not. Yeah, this one's just different. No, I got to flip it around. We are getting the same thing on the dead one. but the dead one is open from base to collector. This is the other one, base to collector. It's fine. Yeah. Collector to emitter. Open, open. Collector to emitter. Open and a drop, which is right. So this one is definitely open. It's got open circuits. That one right there. This one might be okay. I do want to look at the base to emitter junction. Should there be double diode drop base to emitter? Let me look at it. I took pictures of these things, so let me see. Base to emitter, we should have. Yes, we should. Base to emitter. We're getting double diode drop with our black lead on the base. So we put our black lead on the base. We should not have a double, well, we should have one diode drop. You know what I can do? Let me look up. I'm gonna look something up. I'll be right back. Okay, I actually had to grab a good Darlington. This is a tip 120. Test it out, write it out, because I mean, do that. If you get confused about what it's supposed to be, just write out what your findings are. This is a good one, so this is what I should find on a Darlington. Let me put this back. Okay. And this is the one that I didn't quite know if it was good or not. So let's go through what I've got written down here. If we put our red on the base, black on the collector, diode drop. Okay, diode drop, good. Now we move this to emitter, diode drop. That's good. Now let's put our red on the collector, black on base. It's open. And then move this over to the emitter, and it's open. Now let's put red on the emitter and over to the collector, and we should have a diode drop. And I made a note, it's a little bit smaller of a diode drop, and that's that. And then if we go over to the emitter, it should be diode drop times 2. And there's your diode drop times 2. So this one is, and I marked it, this one is good. Okay, now let's test the other one. Same stuff. Darlington transistors are a little more complicated to test, so, and I don't have it down by heart yet of what you're looking for. So for me, I just had to test a good one and write down the results. So here we go. If we put our red on base, black on collector, we get a diode drop, and we don't. There's an open circuit right there. Now if we take black over to the emitter, we should get a diode drop, and we don't. There's an open circuit right there. Okay. Yeah. And now if we take our red to the collector and black to the base, it should be open. And it's not. This one's acting an awful lot like a PNP. No, it's just doing whatever it wants to do. And if we had, okay, our red to the collector over to the emitter, it should be open. And it is, but over here at the base, collector to base should be open, and it's not. Yeah. Now if we go red to the emitter, black to the collector. It should be a diode drop, and it's not. It's open. And if we go from emitter to base, we should have a diode drop times 2. Yeah, this thing's not doing anything. This one is dead, dead, dead. Yeah. So this one's no good. Oh, that's not it. That was that stupid double diode thing. No wonder it wasn't working right. Okay, this one you can see I already marked red. It's no good. But we'll go through the testing. We'll go through the motions here. Red to base, black to collector. Should be a diode drop, and there is none. Base to emitter should be a diode drop, and there is. Okay, collector to base. Red on collector, black on base should be open, and it is. Red on collector, black on emitter should be open, and it is, both ways. Okay. Now emitter, red on the emitter, and black on collector should be a diode drop. Nope. Emitter to the collector. Now if we put a red on the emitter and over to the base, we should have a double diode drop. That's there. The double diode drop is there. But yeah, this one's open a lot of ways. So that one's no good. And these can be replaced with a 2N6059 Darlington transistor. I've already done the spec out. The 6059 is just a higher voltage. They flow the same current, and they have a lot of the same characteristics, so that'll be a good replacement. It's just a little bit more voltage handling capability. And this guy, I've just got to find I got to find something for this double rectifier thing. So that'll do. Okay. Sorry about that. I'll be back. Okay, yeah, this is kind of strange to me. That I looked that chip up, that double rectifier thing, and this thing does not use negative voltage. This board, or does it? What is going on here? Because they're rectifying the negative side of this. If this is common anode, like it says it is, if it's common anode, you have the anode here on the case, right? Here and here. And the two poles of the TO3 case are the cathodes. And this AC is coming in here and here in these two spots and then coming over to the cathodes. Then it's rectifying the negative side of the AC wave. And then this big fat track right here comes all the way down, and this is a capacitor that is filtering negative. You know, the negative side of it is connected to the output of this thing. So that's like a negative voltage. But this doesn't seem to use negative voltage. I'm going to have to really look at it more and find out really what is going on. But anyway, if I can't find anything like this, I can use, and I will use, and just bring over and solder to this a few wires, is the negative side of a 35 amp bridge. I'll just use these three right here. See, this is what we have with this thing right here. This is what we have. According to the schematic, it says common anode. Okay, So this is the case. Common anode. And you got AC coming in here. In here, right? So the negative side of that is being rectified and sent over to the negative end, the negative side of that cap to filter it. It's a full wave rectification. So I can just use this half of this and just disregard this and you know, put my AC here and my AC here and have the negative side of it here for negative voltage. And just not worry about that, because that's where the positive voltage will come out. I mean, if worse comes to worse, I can do that. Yeah, so this thing's no good though. It's got an open diode in it. So this power supply was pretty jacked up, this thing. And it's got, remember, it's got one of these green caps on it. I'm going to go through all of these capacitors. This guy right here looks kind of cooked. That resistor's cooked. So we'll go through, test all these components, make sure everything's good. You know, this transformer looks like it's in super good shape, which is nice. Yeah. Okay. We'll test these caps on our ESR meter, see if they're open. They're probably open. Who knows? This is 50 years old, almost. So we got to do our due diligence and really go through this. Whatever this thing is, what is this? Is this a 305? This little guy? I'll have to find out exactly what that is. I might replace it. If it's a 305, I might just go ahead and replace it. You know. Yeah. Might say, why in the world go through all of this for this power supply? Linear supplies in arcade equipment, linear supplies are always better than switch mode. Switching power supplies create noise. You'll get hum. You might get interference on the monitor. It can just, especially with really old stuff, it can just mess with it. You really want to use the original linear supply if you can, you know. So, and this looks like it's a pretty hefty power supply that can really put out some amperage. So, all right. We'll fix this thing up. As long as the transformer is good, then we'll be good. But if this thing, you know, if this thing kind of is flaky or doesn't work, then we're all done. But this looks like it's in really super good shape, so that's awesome. Okay. All right, so what next? Well, we know we need to order some stuff. We need to get a couple new Darlington transistors. Even though the one tested good, we're replacing both of them with 2N6059. And then this thing, I'm going to, that diode thing, I'm going to see if I can't find. It'd be kind of cool to just find one of these if I can. So we'll figure it out. Okay, and then I've got to order a cap. This thing is a 56,000 microfarad 15 volt. So I'll have to go find me something like that, a cap. It looks like it's like 1.25 inches by 4 inches or something like that. Yeah. Okay. Cool. All right, I'll be back. I'm gonna go ahead and just go ahead and test some stuff on this, and kind of write down, make a list of anything that I remove. I'm gonna put the values down and stuff, and just kind of go from there. All right, I'm going through just testing some resistors and whatnot, and that one that was kind of burnt was open. And now this guy right here, if you can see, I'm going through all of these. And this one, if you can see, is orange brown. That's 331. So this is a 330 ohm resistor. And this one is far too far out of tolerance. It's 500 ohms. Yeah. So that one is going to be replaced. That is R2. And I'm writing it down. I'm going to write down R2. It looks like 1 watt. R2 is 330. And that, is that 1 watt? I'll put 1 watt. My 1 watt resistors will fit good. That one's, yeah. And this cap, I'll show you this capacitor. This is that 1000 microfarad cap. Look at this thing. I don't even want to touch this. This thing has leaked all over everything. Left a nice white ring around where it was too. I'm going to have to clean that up. But I'm going to go ahead and continue on with these resistors. And if they're out of tolerance, they're getting pulled. Okay, and this is what it looks like. This is actually a LM723 in this package instead of a DIP 14 package. So, yeah, I would like to replace that because those things fail quite often. But we'll see. I mean, I hate to get this thing all put back together and then have that not work. That would, you know. I think I'm going to look into replacing that. I might even wire in a dip package to that. You know, I could probably put right here a 14-pin socket. Just drill in a 14-pin socket right there. Kind of run it over, run jumpers over. I'm going to think about that because I would like to not. I don't want to have this thing all soldered in and put back together in that case, and then find out that the 5 volts isn't regulating because of that thing. You know, I just don't want to deal with that. And it'd be nice to have a socket on this board where you can just pop in and replace that in the future. Yeah. Okay. All right, yeah. So I got my stuff all written down, what I've done here. This 3 amp diode, this guy right here, I just didn't like it. It didn't seem stable when it's like a 3 amp rectifier. I'm going to look at the schematic and just verify that. But it looks like when you have your diode test across it, it is not stable. It just keeps going up and down in value, and I just don't like that. So that thing's getting replaced too. Yeah, and here's where that capacitor leaked all over this. So we'll clean that up, get that junk off there. I'm going to do some capacitor checks. We'll check these guys, see how bad they are, and then the ceramics that I pulled off of here, there were 3 of them. I'm going to test those all for leakage. I'll probably replace them anyway, but I want to test them for leakage, see if they were bad, and go from there. Here's a diode too. I got to check that guy. And these 2 tested okay. I might just replace them anyway. They look like they're just 4001 rectifiers. I'll check that out. And that is a 914. I saw it on the schematic. So, okie doke. Okay, and I have drilled a place to put a 14-pin socket right here on the board that will take the place of this. These are the same, the LM723 is the same part as this, just a package that is still being produced today. So, yeah, we're retrofitting here. I just found a spot right here And I'm going to remove that guy right there, and I will just run wires over to here on the bottom side of the board to connect that to the circuit. And that's how we'll do that. Alright, so I'm going to go ahead and remove this. I got the where I'm going to get the hot glue gun out, because I'm going to kind of tack this down to the board, and then so that it doesn't pull out. Yeah, and we'll move forward with that. I still got to wash this. I want to get this crud off of here and clean this up. Everything else that is on this board has been tested and is good, except I have not tested the pots. I'll have to do that, the 2 pots. So I'll do that and make sure that they track right and stuff, and yeah, go from there. I'm just getting ready to remove this guy though. Alright, I actually removed these 2 pots from the board, tested them off of the board, and they are fine. And I sprayed some deoxit in the opening on both of them and worked them really good, and they work just fine. So I'm going to clean the circuit board up, and then we'll start putting it back together. We'll put these guys in. The corner is the 500, and the 5K goes right here. So yeah, we'll go ahead and start. And I've got my the LM723s. There's the 14-pin package, and there's that round one. You just run the wires to the appropriate connection. No big deal. Yeah. Let me clean this guy up, put this thing back together, start putting it back together anyway. And yeah, we'll go from there. And this will be the tale of 2 330 ohm resistors. Let's put our camera in the tripod. Zoom in. And I will measure said resistors. This is the one that came out of the power supply. And it is measuring 466. And here's the new one. 327. So yeah. Alright, we'll put the new one in there and continue on. Okay, so we got this guy kind of put back together. New caps. I got that in the board and just using thermal glue to secure it. I'm going to wait for that to cure, and that thing will never move. You can see the leads are just kind of folded over. You'll solder to those just like that. I got pin 1 marked with the red dot. So there's that. I replaced this capacitor, that little disc, and I replaced that guy right there, the little yellow cap. This is an original cap. It tested good. It's across the line. It's 100 volt 0.1, and it tests good, so I'm reusing that. Replaced this little diode here. Replaced these 2 diodes, and replaced that diode. And just kind of resoldered connections on here. Got the pots back in the board. Those are tested and working great. All the resistors are good. And I resoldered them all. Like I said, I resoldered these connections on the bottom of the board. So, yeah. I just got to wait for parts. I did order everything else that I need. I've got the two Darlingtons coming. I've got this thing. I was able to find this. That double rectifier thing. there was a guy on eBay selling them for $5 a piece. I bought like 5 of them just in case I ever need another one. Yeah. That's it. So I'm just waiting for parts now. I'm going to put this aside and I'm going to move on to starting my harness for the PCB. So yeah, we'll do that and I'll be back. And yes, I have another cap coming. I'm from Arcade Shop. I bought a 56,000 microfarad at, I think it was 25 volts maybe or something like that. It's in the Midway suitcase power supply. It's the same value and it's screw terminal, so that's what I'm using in this. And that was from Arcade Shop. So we got all of our parts to make this thing brand new. So yeah, wait for all that to come in. Like I said, I'm going to start the harness for the PCB and I'll be back. All right, and it may look like a mess, but I promise you it is awesome. What I've done, I've decided to do a redesign on this with modern parts. The thing I don't like about this design is it's just not accessible. You cannot work on this because this thing is mounted to that case right there through the soldered Darlington transistors and that 711A dual rectifier thing. I don't like that. It's just not accessible. You can't work on this. I want to make this to where this is in the future nice and easy to work on. You can take it apart easy. It just unhooks and comes apart. So that's what I've done here. We have, number one, here's that LM723. And then I'm bringing the amps, the Darlington amps out. And this is the that dual rectifier thing coming out. I need to crimp spade terminals, quarter inch spade terminals that will plug into a bridge because I am using a 35 amp bridge rectifier, and these two leads will be going to the AC. This lead will be going to the negative of that, just like in this diagram right here. You can see this is that dual diode thing, okay? And you can see the AC. This is kind of strange. I've never seen a power supply set up like this, and this drawing is missing a diode. There's another one of these 1 amp diodes. You can see there are 2 of them right here, CR3 and CR4, the 2 diodes. Yeah, these this is not. Yeah, this schematic is goofy. This schematic does not really match this. It's some of it does, but yeah, it's not a very good schematic. But you have the dual diode thing right here, and AC is coming into the cathode banded end, which means they are setting ground through this thing. This is the ground. The ground is the negative side. The negative going part of the sine wave is being rectified and then filtered right here through that. That's the big 56,000 microfarad cap that is filtering both the positive voltage coming in. It looks like they're using 10 volts center tap, because I did test this. I know I'm all over the place. I tested this, plugged this thing in. This transformer works good. It outputs a 20 volt peak to peak sine wave center tap. So it's 10 volts center tapped each way, and it's peak to peak 20 volts. So it looks like they're using, I mean, I did not beep this out. I'm not really trusting this schematic completely because it just doesn't make sense. How can you have, okay, the center tap, is it grounded or is it just floating here? What's going on here? this C2. What is C2? You know, I don't know what's going on there. It looks like this diode would be rectifying the center tap and then grounding it, or I don't know what's going on. No, this should just be grounded. But they're setting the overall ground through this. You can tell. So that's the ground reference. That's where they're putting the reference voltage, and then everything above it is positive volt. There's no negative voltage on here. And this is that can thing that I replaced with this guy. Yeah, and this only has one Darlington amp on here, and this thing has two of them, so that's missing on here. Yeah, this is a bad schematic. Really half-ass. Exidy really kind of crapped the bed when it come to this. Yeah. Not a good schematic at all. But anyway, so yeah, I'm going to hook the two leads coming off the transformer are brown and white. It's these two guys right here. Those are the two cathode ends right there. So the AC comes into there. It's going to go into my bridge rectifier, and this will be hooked to the anode side. Yeah. Yeah, I drew that out somewhere. But anyway, yeah. Let me draw out a bridge rectifier again, so I got to make sure this is going to work. Yeah. After drawing out, this is a bridge rectifier. You got your AC wave here, you got your AC wave here. And these are the cathode end side, and this is the anode. The common anode is right here. It's the negative part of the voltage of the bridge. You can see that's what they're doing here. You got AC coming in on the cathodes, and then the anode is common. So I'm going to use this bridge rectifier and just disregard this and hook my AC in and put that purple lead right here on the negative part of the bridge. And that'll complete that circuit. So that'll do. Yeah, this is what it looks like on the back. These will lay down. Kind of got those protected with some glue, and the purple wires are the collectors to the transistors, and then the anode end of that bridge. Yeah. These are the collectors are all tied together. So they're using two in parallel with each other, it looks like. I'm going to draw that. Let me draw that out and see what is going on here. Yeah, I beeped it out, and the two bases are 0 ohm to each other. They're shorted to each other. The bases are shorted, the collectors are shorted, and the emitters are shorted. So this thing is just acting as a double amplifier, I suppose. It's in a common collector setup. So the input is coming off onto the base, which is coming from this chip. Pin 6 is the voltage out. You can see pin 6 is V out. So the voltage out is going to the base to bias this transistor. And maybe this is Q1 is both of these. I don't know. But yeah, the current comes in to this collector. This is turned on by the base emitter junction, and it's just passing current. It's a pass element. It's a double pass element. It is providing current for the 5-volt regulated output is what it's doing. But it's set up in a weird, I've never seen this, a double Darlington setup. I've never seen that. But yeah, interesting. But what I'm using is modern Darlington amps. I spec'd them out against what was originally in this, and they both, they flow. The ones I'm using are good up to 20 amps continuous collector to emitter current. The ones that were original are 12 amp. And the power dissipation, the originals were 150 watt. The ones I'm buying, the ones that I bought are 160 watt. So they're really the same part. It's just a little, it's got more voltage tolerance and it'll pass more current. So it's a little bit beefier. So it'll work great. And then we'll have our bridge rectifier here. And that's it. I'm going to actually put this thing back together in the case. And all I have to do is put the parts in when I get them. All right, and here it is. You can see I have a quick disconnect here where all of the wires from the transformer are here, and then this plug goes to the board. And then I put a quick disconnect in here as well. And then these guys, I'm going to have the two Darlingtons. They are in a TO247 package, so I'll show you exactly what they look like. I bought them from Mauser. I got to wait for them to show up. Tip 35. Tip 35. Where are you? Am I looking right at it? Where are the tip 35s? There they are. They look just like this. They will be mounted upside down like this with a mica insulator and paste. They're going to be mounted just like that. Here and here. And now this connector will not go into here. It doesn't line up right. You can see if I can do this. Yeah, I can't do it. Yeah, you see it doesn't quite line up right. So what I'm going to do is kind of cut these off right up there. And I'm going to solder a section of three 0.156 headers to that so that I can put this on it. So I'm going to cut these right about here. I'm going to cut them. And then get a 3-pin 0.156 that fits into these. Solder it onto there. Put a little heat shrink up on it so that I can plug these in on it. Yeah, and then these will be mounted like so. Yeah. And then the bridge will be down in the corner. I'll have to drill a hole to mount the bridge and put heat paste on it, and then this thing will be the heat sink. Yeah, pretty slick. And I got the cap coming, so I'll have to mount this thing in there for the cap. And we got our power. So yeah, it's going to be nice. I used the exact same mounting screws that were there, and I used the little green. You can see the spacers, the little insulators. I used the insulators, of course, to insulate the board against the case. And that's it. So I'll have to wait for my parts. And when we do get our parts, I'll go ahead and put it together. And then I'll put a load across it, across the 5 volts, and test it. So yeah, cool. That's it for that for now until I get those parts. So let's end this right here. Part 1 is done. And we'll move on to more stuff when I get more stuff.